the extension. I don't know how much this kind of diagram, figure 9. This puts the basin and range kind of in the chronology of the tectonics. We're in this lower stage. This may be familiar to you, but you always have to work with big concepts as well as observational scale things. If you go back as far in time as 75 to 55 million years ago, the Pacific seafloor and associated materials were moving fairly flat underneath North America. Rapid convergence drove one plate practically flat beneath another. And the compression of the plate below against the bottom of the overriding plate gave so much compression that we had basically what is described as the laramide orogeny, mostly thrusting, converging tectonics. After the convergence in the laramide between 75 and 55 sort of slowed down, that is the amount of convergence, the plate began to steepen, being pulled down, and it actually detached, this one model suggests, and moved down and out of the way to allow new, hotter, warmer at least, asthenosphere to come up into the space where the plate, which was horizontally arranged, detached and moved away. So you wind up bringing a lot of very warm material up against, sweeping up across the bottom of a zone which had been protected by a plate below. So you drop that, you bring hot asthenosphere up, you stretch it, you pull it apart, you cause melting, you cause all the parade of beautiful extension structures, but you also bring up enough heat to cause melting that Dr. Anson's going to talk about later.
And the other model for that we talked a little bit about in class was the fact that, you remember, I think it's about 40 million years ago, if you follow the Hawaii temperature chain, seamount chain, there's a huge bend in the chain right about there. And that's, if you notice, it's about the same age as this. And about there, you're taking the Fuka plate was going under, and you subducted a spreading zone. So you subduct that divergent plate boundary. Well, it's not going to stop spreading just because it's gone underneath the North American plate. It keeps spreading underneath. It's still an active ridge zone, and so that's another thought for why you get that heat flow underneath here. So one way or the other, you're generating melting and increasing the heat flow, which then domes, because it's less dense, it domes and stretches the crust, and then it slides down the asthenosphere-lithosphere boundary, pulling the whole thing apart, and above whatever 15 kilometers where we get brittle deformation.
And volcanics.
And volcanics coming up, yeah, it's just incredible.
This is just one of many. There are intra-arc models, there are rollback models for plate tectonics. This is just one. This is just speculative. But if you're interested in big picture changes from convergence to divergence,
well, I think it's important because it allows you to tie what's going in here to features on the seafloor out in the middle of the Pacific Ocean, which I think that's the beauty of plate tectonics, its ability to pull everything. It was a major plate reorganization 43 million years ago. 43.
Yeah, and I think there's a new textbook. I'll check with you about maybe tomorrow sometime about this diagram, which is figure. Can't read it upside.